In this video, we're going to explore projectile motion in a little bit more detail than we discussed this morning. And we're going to cover these topics. What is a basic definition of projectile motion? How do we think about the X and Y components of a projectile? How do we put those two together to come up with a projectile's trajectory or path? And then in a later video, we will investigate how you analyze motion and solve problems related to an object's motion. So we explored a couple of scenarios this morning. A Red Cross airplane that's dropping supplies on an island, or two cannonballs that are launched at the same time. One is launched with the initial horizontal velocity and the other is dropped straight down. As well as a car that's moving in one direction and projecting a soccer ball out the back in the other direction. A child being pulled in a wagon who tosses his toy up in the air. So what all of these scenarios have in common is that they include both a horizontal and a vertical component of motion. The definition of a projectile is any object that's freely moving through the air and influenced only by gravity. That means there is no air resistance that's significant in this object's motion. Although, of course, on Earth there's always some air resistance, but there are certain objects that we can discount that and assume that it's not important. These include objects like balls that are being pitched or thrown or dropped or tossed up in the air. It includes bullets and arrows, things with minimal air resistance. But it doesn't include things like parachutes and frisbees that have a significant amount of air resistance. And it also doesn't include objects that are powered, like rockets or airplanes. Projectiles can have both horizontal and vertical components of motion. So unlike problems in the first unit where we were only talking about one-dimensional motion, projectile might have been something that was thrown straight up or thrown straight down or dropped. Now we're going to consider objects that also have a horizontal component. A key component in analyzing two-dimensional motion is recognizing that perpendicular components of motion are independent. So I want to review what we learned when we were studying vectors earlier. And you'll remember that any vector that's not in a nice north, south, east, west, up, down direction, for example, this purple vector, can be broken down into its x components and its y components. So x in this case is horizontal and y is vertical. It can be broken down into x and y components, and let's say this is displacements. So let's say you walked some distance in the x direction and some distance in the y direction. If you continue to walk in the x direction from this point, it doesn't change anything about your y component of direction. Likewise, if you moved in a y direction from this point in time, it doesn't change anything about the x component of motion. So this is true about displacements. It's also true about velocity vectors. It's also true about acceleration. And it's also true about force vectors, which we will be studying in our next unit. This has been experimentally proven that perpendicular components of motion or any vectors are independent of each other, and neither the x component nor the y component is changed by the presence of the other. What this means in terms of evaluating projectile motion is that we evaluate the y component of motion separately from the x component of motion. So we've already practiced evaluating objects in free fall, and we know how to determine things like its initial velocity or displacement. And we also know that the acceleration of an object in free fall is 9.8 meters per second downwards, regardless of the initial speed or the angle that it's initially thrown or projected. We evaluate the y motion exactly the way that we've done earlier. So if this were not displacement vectors, but instead they were velocity vectors, and let's say this object was thrown at an initial velocity at some angle to the horizontal, then to evaluate the y motion, all we need to know is the y component. Likewise, when we're looking at the horizontal motion, what's happening in the vertical direction has no bearing. The x component of motion, the horizontal direction, it remains constant. Since there's nothing causing the object to accelerate in the x direction, assuming there's no air resistance, then that becomes a simple constant velocity problem. And the displacement is a function of the velocity and the time the object is moving at that speed. And that horizontal displacement is sometimes referred to as the object's range. So to fully describe a projectile's motion, we have to put those two pieces together, both the horizontal and the vertical parts. And when we do that, we come up with a path similar to the red ball that's being fired from the top of a cliff. So notice that the x component of velocity here, it's initially fired at a horizontal velocity of 100 meters per second. And as the time ticks by, that isn't changing. Again, there's nothing acting on it horizontally that would change that. Vertically, on the other hand, as soon as the object is fired from the cannon, it starts to accelerate downwards at a rate of about 10 meters per second. So notice that the y component of velocity is changing, it's increasing by 10 meters per second every second. If you put those two paths together, both the gravity-free horizontal path, the combination of those two motions gives you a parabola shape. So we can go back now to look at the Red Cross airplane that's dropping a package on an island. And we know that the path of that object is going to take a parabolic trajectory. So if I set this plane in motion, and anticipating that it's going to follow a parabolic trajectory, I can drop the package at the appropriate time. Thanks to physics, we can save the people who've been stranded on the island. At the moment the package is released, it's already traveling with the horizontal velocity, which is the same as the velocity of the plane. What we're going to experiment with in class is how does that initial horizontal velocity impact the time it takes an object to fall to the ground. In the next video, we'll learn some techniques for analyzing two-dimensional motion, and we'll practice a few problems.